regarding the allele frequency and genotypic frequency of ABO blood group using Hardy Weinberg equilibrium law. Let's see the question. Sampling of 200 persons for their ABO blood group was done from an urban area. The type of blood group observed in the given population are as follows: A blood group 60, B blood group 32 individuals, AB 10 individuals, and O blood group is 98 individuals. Now question is that which of the following gives the correct frequency of blood group determining alleles IA, IB, IO in the given population. Four options are given. You have to choose the correct one. So here total individual or total person is 200 individual. The observed individuals of A blood group 60 individuals, B blood group 32 individuals, AB blood group 10 individuals, and O blood group 98 individuals. So we will use the Hardy Weinberg law to solve this kind of problems regarding ABO blood group. So let's start the calculation. So as we know previously that P plus Q is equal to 1 where P is the dominant allele and Q is the recessive allele, and they are in Hardy Weinberg equilibrium, so the value will be P plus Q is equal to 1, or P plus Q whole square is equal to 1. So P square plus 2PQ plus Q square is equal to 1. This is already known. Now we will what we will do is that we will take P plus Q plus R. So we will take P plus Q plus R, three variable, is equal to 1, where P is equal to frequency of IA allele, Q is the frequency of IB allele, and R is the frequency of IO allele. Now the interesting fact is that when you will try to calculate the frequency of A blood group, suppose A blood group, this A blood group has IA allele plus IA IO allele. So you will not be able to directly calculate the IA or IA IO. But in case of O blood grouping, say O blood grouping, there will be the frequency of only OO genotype. So in this type of question, you can directly get the value of O blood group genotypic frequency by calculating the total individuals divided by total. So we'll do this part. Now let's say that R is equal to frequency of IO. So R square or frequency of IO, that is the genotypic frequency, is equal to 98 individuals by 200 is equal to 49 by 100 is equal to 0.49. So we have got the value of frequency of I0, the genotypic frequency. We can summarize as R square is equal to 0.49. So R is equal to 0.49 over root. So root over 0.49 is equal to 0.7. So we have got the value of R, that means the allelic frequency of O individuals. So now go back to the question. You can see that the first option has the allelic frequency 0.7, third has 0.7, and fourth has 0.7. So we will just eliminate option 2. Now we have to further calculate the frequency, allelic frequency of IA and IB. So let's do that part. So as we have written that P plus Q plus R is equal to 1, as I have already mentioned, so we will take P plus Q plus R whole square is equal to 1. So P square plus Q square plus R square plus 2PQ plus 2PR plus 2QR is equal to 1. This is just a simple expansion. Now we may say that the frequency of P square is equal to the genotypic frequency is equal to IA. Frequency of R square is equal to frequency of I0 and 2PR is equal to frequency of IO. This is you may say that this is also related to this expansion. Here P square, 2PQ and Q square. We have simply used this formula here to get the value of P square plus 2PR. Now ABO blood group, ABO blood group, A blood group has both the allele IA plus IO. So here we may write that P square plus 2PR plus R square is equal to 60 plus 98 by 200 is equal to P plus R is square is equal to 79 root. So P plus R is equal to 0.88. You may use the calculator to calculate this value. So we have finally got the value of P plus R. As we have already got R is equal to 0.7, so P plus R is equal to 0.88. P is equal to 0.88 minus R. P is equal to 0.88 minus 0.7. P is equal to 0.1888, so on. So P is equal to nearly equal to 0.19. So we have finally got the value of P is equal to 0.19. Now we already have that equation, P plus Q plus R is equal to 1. Now we know that P is equal to 0.19 and R is equal to 0.7. So Q is equal to 1 minus 0.88. So we may also use one step, that 1 minus P plus Q is equal to 1 minus 0.19 plus 0.7 is equal to 0.11. So Q is equal to 0.11. So finally we have completed the whole equation and finally got the value, that is P is equal to 0.19, Q is equal to 0.11 and R is equal to 0.7. So the option 1 is the correct option. So using this simple technique you can solve this kind of problem very easily. Thank you for watching this.